3.
Welcome to the bond number review.
As with all reviews, major understandings are in bold, and practice questions can be found under each of the major understandings. Here we are looking at the basic principles of chemical bonding. We know that chemical bonds basically form so that atoms can obtain stable, noble gas electron configuration. In general, in chemistry, 8 is great, as 8 is the valence number of electrons of noble gases. But don't forget, 2 will do for hydrogen, as hydrogen only desires a duet or 2 electrons to fulfill its valence shell, since it only has one principal energy level. Here we can see a big compare and contrast between the two major types of compounds. Different compounds are characterized by their kinds of bonds. There's ionic bonds. In ionic bonds, electrons are transferred from the metal to a nonmetal, while in covalent bonds, electrons are shared between two nonmetals. Because of the movement of electrons and their attractions, again, all in order to obtain stable noble gas electron configuration, different types of compounds have different physical properties. Ionic bonds have very high melting points and boiling points, and they conduct electricity either in aqueous or in the molten state. Ionic compounds in general have very extreme physical properties, and this is due to their very extreme difference in electronegativity. Having a great electronegativity difference, any value of 1.8 or higher, ionic bonds have one atom that completely loses its electrons and another one that gains all of the electrons, and they have very strong electrostatic or charge interactions. Meanwhile, covalent bonds, the two atoms within the bond will have very similar electronegativities, so they have very small electronegativity differences. So, since they are about equal in their ability to attract electrons, in covalent bonds, electrons are shared, and again, they're shared to obtain stable noble gas electron configurations. Because there's a less extreme difference in electronegativity, the electrostatic attractions from one compound to another are quite weak, so they have very moderate physical properties like low melting points and boiling points. They are never electrolytes, and they are soft. Substances that are electrolytes or conduct electricity must have moving electrons. Now, in the solid state, a ionic compound does not have moving electrons. Instead, their ions vibrate in fixed geometric patterns. But in the liquid and molten state, there is flow, so these ions can flow past one another, creating a flow of charge or electrons, which allow the conducting of electricity. Covalent compounds, they do not have these charges, and they will never conduct electricity. Now, the other type of bonding that we should look at is metallic bonding. Metallic bonds occur when metals bond with themselves. Metals have very low valence electron numbers and very low electronegativities. They don't have great desires for electrons in a bond. In order to obtain stable noble gas electron configurations, what metals will do is that they will delocalize their electrons. They'll spit out their electrons, and they'll allow the electrons to flow freely, kind of like a Congo line in a sea of mobile electrons. This sea of mobile electrons contributes to the physical property that metals conduct electricity, including in the solid state, because their electrons are flowing around. They're at all times, they're always mobile. They are malleable, meaning that they are bendable, and they are ductile, meaning they can be drawn into wires. So the first question is a review actually from Unit 1, and it asks us to find which describes a chemical property. Now, recall that chemical properties are properties that involve reactions or changing of a substance from one substance to another. Versus physical properties, the identity of the substance doesn't change. For instance, melting of ice is a physical property. because you begin with solid water and you end with liquid water, but you did not change the identity. So in this case, here we're looking for a chemical property that can distinguish two compounds from one another. So the state of matter, the fact that it's a solid given in choice A, would not tell the two apart. Now, melting point is not a physical melting point is a physical property. It's not a chemical property, because when you melt something, you don't change it. So although melting point can distinguish something, this is a physical property. Now, dissolving is another physical property. So if I take sugar and I place it in water, I still have sugar. So that's a physical property. Now, burning something, now that is a chemical property. And so burning causes a chemical change. So if I take a piece of wood and I burn it, then it is no longer wood. It is ash. So that's a chemical change, and that's described through a chemical property. And the next question, the key word here is covalent. Remember that covalent sounds like cooperate or coordinate. And when you cooperate or coordinate, you share your electrons. This is a simple definition. Now, in the next question, it asks which molecule is nonpolar. The topic of polarity will not be covered on our first bonding exam, but we'll review it anyway. So here we're asked about which molecule is nonpolar. And actually, in addition to nonpolar, the word molecule is really vital. A molecule is nonpolar when it has symmetry. So we also talked in class that a shortcut to figure out if a molecule has symmetry is if it ends with a even-numbered subscript. So looking at all the formulas, so H2O, the last subscript, the subscript for the oxygen is 1. That's an odd number. Carbon monoxide, the last subscript is a 1. Here, ammonia is a 3, so carbon dioxide is the best choice. When we draw out the structure of carbon dioxide, carbon has 4 valence electrons, and so when we place them around carbon, carbon is the central atom as it lacks a subscript. What we'll do is we will draw bonds and connect our peripheral atoms as far apart as possible. Oxygen has 6 valence electrons, so remember that the bond is the first electron. So this is 1, 2, 3, 4, 5, 6, and then our next oxygen is 1, 2, 3, 4. We always skip over the line, 5, 6. So here what we're left with is we're left with some lone unpaired electrons, and we'll pair them up to form multiple bonds. So we can see that this structure has symmetry, making it nonpolar. Question number 4 repeats a question about polarity and symmetry. So here we have carbon tetrafluoride. Now, again, we can use the shortcut that we'll just simply look at the subscript. So if the subscript is even, then it's going to be nonpolar. And the subscript is odd, then it's going to be polar. Carbon tetrafluoride, 4 is an even number, meaning it is nonpolar, and nonpolar is due to symmetry. We can draw the carbon tetrafluoride and see that it is perfectly symmetrical. Question number 5 again is asking us to pair bonding. Now, when we are looking at bonding, the simplest way is to identify the types of atoms in the bond. So let's take a quick note. So here, ionic bonds are always formed between a metal and a nonmetal, while nonpolar covalent bonds are formed between two identical nonmetals. Polar covalent bonds are formed between two different nonmetals, and metallic bonds are formed between a metal with itself. Now this concept of polar and nonpolar bonding, again, will not be present on our first bonding exam, though we'll review the question now. So here we have sodium bromide. So when we look on our reference table, let's pull up the periodic table. Here we will recall from our last unit that the metals are located to the left of the staircase. The nonmetals are located to the right of the staircase, and metalloids fall in the middle. So sodium bromide, sodium is a metal, and bromine is a nonmetal, thus making it ionic. So this choice is not correct. Instead, it is ionic. Now, hydrochloric acid, here we have hydrogen and we have chlorine. These are two nonmetals. Remember, hydrogen is in fact a nonmetal, making it a covalent bond, but since they are not the same element, it will be a polar covalent bond. So this is not acceptable because it is a polar covalent bond. Now ammonia contains nitrogen, which is a nonmetal, and hydrogen, which is a nonmetal. And they are different nonmetals, so that means two different nonmetals will have a polar covalent bond. So ammonia is our best choice. And lastly, we're given diatomic bromine. Now bromine is a nonmetal, it's located here, but it is the two identical nonmetals, thus making it nonpolar. So this would be nonpolar. Next, we were asked about a lithium ion as it is formed from a lithium atom. So let's pull up our reference table and find lithium, atomic number 3. So here we find lithium. Lithium is a metal, and it has, when its atom forms an ion, it forms a positive 1 charge. Now recall that atoms have, when they form an ion with a positive charge, they're losing their negative electrons. So in this case, choice 4 would be the best answer. Now, next it asks, what change occurs when a barium atom loses 2 electrons? And we want to look at barium. Barium is here, element number 56. And we can see that it forms a positive 2 ion. So it's going to become a positive ion. So we can immediately eliminate the first 2 choices. And then it asks what occurs to the radius. Well, here is the key word lose. If you lose anything, electrons, weight, anything, you're going to become smaller. So its radius will decrease. The next question asks, which compound contains both ionic and covalent bonds? We can recall that ionic bonds are formed between metals and nonmetals, while covalent bonds are formed between 2 different nonmetals. So in this case, we're looking for something that has a metal and a nonmetal, and then 2 different nonmetals. So here we know that calcium is a metal, and we can look at our periodic table to verify that. Let's pull that up. Okay, so now we have calcium here, element number 20, which is a metal, and then it is calcium carbonate, and it has carbon. Carbon is a nonmetal. So there's a metal and a nonmetal, and then there's an oxygen, another nonmetal. So metal and nonmetal, ionic, and nonmetal covalent. So calcium carbonate is the correct choice here. And we can see that here we have phosphorus trichloride. In phosphorus trichloride, we have phosphorus, which is a nonmetal, and chlorine, which is a nonmetal. So that only has a covalent bond. Magnesium fluoride, magnesium a metal, fluorine a nonmetal, that is an ionic bond. And then here we have a carbohydrate, carbon with hydrogen and oxygen, all nonmetals. So that would be only covalent bonds. Now it is important to remember that any compound that contains a polyatomic ion, like those found on reference table E as an elephant, will have both ionic and covalent bonds. Next, we are asked to go and evaluate the type of bond between hydrogen and oxygen. Now, when we look at a bond between hydrogen and oxygen, we have to evaluate the type of bond. Here we have hydrogen, a nonmetal, and oxygen, also a nonmetal. So when 2 nonmetals bond, we have covalent bonds. So ionic bonds are between metal and nonmetal, and metallic bonds are between metals and themselves. So we can eliminate these 2 choices. Now, we need to ask ourselves, is this a polar covalent bond or a non-polar covalent bonds? Now, recall that polar covalent bonds are bonds between two different nonmetals, and non-polar covalent bonds are only between two identical nonmetals forming a diatomic molecule. So here, polar covalent bond is the best choice. We are next asked to evaluate what occurs when hydrogen and chlorine form hydrogen chloride. Now we can see that when hydrogen and chlorine form hydrogen chloride, we form a bond. The reason why elements choose to form bonds and make compounds is that together in a compound they'll use less energy, allowing the excess energy to be released. Forming bonds always releases energy, and breaking bonds, just like breaking up a couple, always requires energy. Question number 11 asks, a substance that does not conduct electricity as a solid, but does conduct electricity when melted, is most likely. Now this is a pure definition of an ionic compound. Remember that electrical conductivity requires mobile electrons. Question 12, the key word here is molecular. The word molecular is synonymous with covalent. Now when we have a covalent compound, we have two nonmetals. Being that we have two very similar atoms, again, both nonmetals, they'll have very similar properties. And one of the physical properties is low melting points. Now, conductivity of a metal always results, and all conductivity results in mobile electrons. So choice 4 is the best choice. Metals have very low electronegativities, low ionization energies, and protons never contribute to electrical conductivity. The final question on this page asks us to identify the correct Lewis electron dot diagram for a boron atom in the ground state. Now, what we first need to do is refer to our reference table and find boron. So here we can see that boron is element number 5. In the ground state, its electron configuration is 2-3. We're going to use this to help us draw the Lewis dot diagram. So recall that when we draw the Lewis dot diagram, we're going to simply place the element symbol, and then we may place dots around the symbol on directional coordinates north, east, south, and west. The rule is you can only place one dot per directional coordinate until you have satisfied the valence going in a circular pattern. So in general, the pattern is 1, 2, 3, 4, 5, 6, 7, 8. Now boron has a valence of 3. So boron would have 3 valence electrons. If I were to illustrate the Lewis dot diagram for boron, I would do so like this. Notice this is not a choice given. But again, our valence is 3, and only one of the diagrams has a boron atom with only 3 electron dots. So choice 2 is the best answer.